In this video, we'll use COMBINA and COMBIN to generate the Taylor-Maclaurin series expansion of the binomial series Pascal triangle coefficients. We begin with the 1 minus x. So this is equal to R, the formula. The quantity 1 minus x raised to the power k. And 1 plus x. So this is R, the formula. The quantity 1 plus x raised to the power k. And the value of k, which is data validation, list of items. Let's start with 0, 1, 2, 3, 4, 5, 6. Let's say 6. So at 0, that's 1, 2, 3, and 4. Now we continue with the Taylor-Maclaurin series of expansion, which is the summation of a times x to the power n, where a comes in a1, which is c to the power n combined k comma n, and a2 will be c to the power n times combina k minus n plus 1 comma n. And the value of n is 0 to infinity. In this case, we can go as far as 16, which is good enough. Now we can calculate the combina. So R, a formula, that is c to the power n. C raised to the power n times combina k minus n. So k minus n plus 1 comma n. Enter. Now our value for c will be data validation, list of items, minus 1 if it is 1 minus x, and 1 if it is 1 plus x. We start with minus 1, with 1. So this should be 0. So to correct this, we'll condition that if n is greater than k, then 0. So the condition will be if n is greater than k. If it is greater than k, then 0. Otherwise, calculate. Now it's corrected. And these are the Pascal triangle coefficients. We'll do the same with combina, with the combine function. So R, a formula, c to the power n times combine n comma k, or k comma n. So k comma n. Enter. We'll apply the same correction. That is, we have this correction, comma 0, comma. If n is greater than k, if n is greater than k, then 0. Otherwise, calculate. Now it's corrected. Now we can continue with the expansion. So R, the formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1. And the coefficient, you can choose a1 or a2. Let's start with a2. And enter. So their values are the same. So we'll chart this. Insert chart. and we'll use scatter chart. And apply trend line. Series, trend line, polynomial to the 8th degree. For the label, we use the equation. For the legend, position it at the bottom. And we'll change the series of 1 plus x to green. Change it to green. Now that matches the data. And for all the series, the point size will be maximum, except for the expansion, we will change that to none, but the line thickness will be maximum. So here we have the trend line and the polynomials of the trend lines. So if C equals -1, the red line is on the blue data set. So this approximates 1 minus x to the power k. If it is +1, the red line is on the green, which means that the series sum or the expansion approximates the 1 plus x to the power k. Our k is from 0 to 6. We'll calculate these regression coefficients using LINEST. To do that, we complete the LINEST matrix starting with transpose 0 to 8. And the elements, this is RA formula of the x values raised to the power 0 to 8. Enter. And we calculate LINEST starting with the 1 plus x, 1 minus x. So LINEST data y and data x. Enter. And the expansion. So LINEST data y and data x. Enter. And the 1 plus x, so LINEST 1 plus x to the power k. Dot data x. So here we have the polynomial regression coefficients. Let's compare. Starting with 0. At 0, they're all the same. So that is 1. The value is 1. At k equals 1. So that is 1 minus x. So this is 1 minus. So the red line, the expansion approximates the 1 plus x. So if I change the value of c to negative, the regression coefficients are the same for the expansion and the 1 minus x. So at k equals 2. So here we have our Pascal triangle coefficients. So -1, 1, -2, 1. These are the Pascal triangle coefficients. And the red line is on the blue. That means the expansion approximates the 1 minus x to the power 2. If I change this c to +1, this time the expansion approximates the 1 plus x squared. So their polynomial regression coefficients are the same, and their polynomials are also the same. We increase this to 3. This time our Pascal triangle coefficients 1, 3, 3, 1, which is the same as the 1 plus x, because the red line is not on the green. So the expansion approximates the 1 plus x to the power 3. If I change c to negative 1, the series the expansion approximates the 1 minus x to the power 3. And the regression or their Pascal triangle coefficients are the same, and their polynomials are the same. You can go as far as 4, and you can change toggle from negative 1 to positive 1. And this completes the use of COMBINA and COMBIN to generate the Taylor-Maclaurin series sum expansion of the binomial series Pascal triangle coefficients.